Okay, let's talk about voltage, current, and resistance within a circuit. Now, the voltage we're going to label as the letter V. The current we're going to label as the letter I, and resistance we'll label as the letter R. And Ohm's law says the relationship between these three is that voltage comes from the product of I and R. Or should I say voltage comes from multiplying the current and the resistance. So let's talk about what can represent voltage, current, and resistance. And a great example is tanks of water and the pipes between the tanks. So the tank that holds the water, that's the voltage. It has basically all your potential power. So the more water you have in the tank, the more potential power you have. Same thing as having volts. Current is basically the water flow through the pipes. You can have a lot of water flow, a little water flow. Just like when you turn on the faucet, you just turn it on just a little bit, you get a little bit of water flow, and you turn it all the way, you get all the gushing water. Okay, current is basically whether you have a little or a lot of flow through the pipes. Okay, now what manages how much water flow you have is the resistance. Resistance manages the water flow. In our case, it's actually electron flow. In other words, it slows or increases the electron speed through the wires, just as though you were controlling the speed of the water through the pipes. Okay, now in a if your pipes lead out of the power source, which is our volts, but does not come back, that's called an open circuit. No water flows in that, or should I say, there's no electricity flow if you have an open circuit. The middle one is pipes are actually leaving from the voltage tank and actually come back to the voltage tank. If your power goes out and comes back in, that's called a closed circuit. Electricity does flow there. In our example, we would show that water flows in that situation. Okay, now resistance would be any type of way that you can slow the water down. You can use a knob. Here we use electronics. Now we do have things that only do resistance. That's all they do. They call resistors. But anything you put in that water flow situation is going to essentially act like a resistance. Okay, but we do have resistors. That's all they do. They don't do anything else. Okay, next. So let's take a look at Ohm's law. Let's say we had 30 volts of potential power. That could come from 3 amps flowing through the wires and 10 ohms of resistance in the wires. Okay, 3 amps of current and 10 ohms of resistance would give you 30 volts. Let's keep the voltage the same, 30, and then start decreasing the resistance, or decreasing how much water we let through. We're kind of letting more water through, basically. The less resistance. Well, if you have less resistance, what happens to the amps? Well, how do you get 30 volts again? Your amps would have to go from 3 to 5, because 5 amps times 6 ohms would give you 30 volts. And you notice that the amps are starting to go up while the ohms go down. So let's take our ohms down a little bit more. Our resistance now is 5, and our volts, the water in the pool, stay the same. So what would be the speed of the water now, or the current? The current now would be 6. It goes up to 6. Let's take our resistance down more. Let's make it 3 ohms. Well, what would our amps have to be? It would have to be 10 in order to match the 30 volts. So the water is flowing faster and faster and faster, the less resistance we're giving it. Let's keep decreasing the resistance. Now the resistance is 2. Well, what would the amps be? Well, 15 times 2 would be 30. So your amps would have to be 30. So the water speed, or the electron speed, is now speeding up. And the faster and faster your electron speed goes, the more hazardous it is to be shocked by it. The stronger shock you're getting. Your shock actually comes from the electron speed or the current out of those three. Not from the voltage, not from the resistance, from the electron speed, the current. So let's make the resistance even smaller. Let's let even more water go through there. So now it's down to 1. Well, your amps would now have to be 30. So from 15, now we're at 30 in order to have the voltage to be the same. Let's decrease it one more time. So now it's 0.5. It's really small. Well, what would the voltage, and the voltage being 30, what would the current have to be? The current would have to be 60 times 0.5 would be 30. So, in conclusion, Ohm's law says that the current I and the resistance R are in an inverse relationship. That means as one gets smaller, the other one gets larger. Or as one gets larger, the other gets smaller. Now, let's start again. This time we have 60 volts that has been made from 6 amps in the circuit and 10 ohms of resistance. Now, let's start increasing the voltage. We're going to put more and more water in the tank, and we're going to see what happens to the speed of the water through the pipe. So you have more and more water in there, and you keep the resistance the same. You're not going to change the knobs. Well, in order to have 70, your amps would have to go up to 7. So you used to have 6, now you have 7. So as your volts go up, your amps are now starting to go up as well. Well, let's say your volts go up to 8. Your amps would, 80, should I say, your volts are up to 80. Your amps would now have to go from 7 to 8 amps to keep up with the volts. So now you got more water flowing because now you're up to 80 and it's really pushing the water through those pipes. Let's take your volts up to 100. Well, what would your amps have to be now? Well, now it would have to be 10 because 10 amps times 10 ohms will give you 100 volts. What if you had 100 volts, just almost a full tank of water pushing through your pipes? Well, your pipes would have 15 amps. Very, very, very dangerous to touch the wires with 15 amps running through them. Okay, so Ohm's law says that the voltage V and the current I are in a direct relationship. That means as one increases, the other one increases. Or if you went backwards, as one decreases, the other decreases. Now, let's take the same situation. We're going to increase the volts again. Now we're at 10 volts, made from 5 amps and 2 ohms. Well, what if you wanted the water speed to stay the same, but you kept increasing how much water was in the tank? Well, what would you have to do with the ohms? Well, let's say you want the water speed to stay at 5 amps, but now you went from 10 to 20 volts in there. Well, your resistance will have to go up to 4 because 4 times 5 will give you 20. Now your resistance is going from 2 to 4. It's increasing. Let's say your voltage increases to 50, and that's how much water you have in the tank. But you want those amps to stay at right at 5. So what would you have to do? You have to increase the resistance to 10. If your voltage was at 100, you really plug in lots of power, potential power. But you want the amps to stay at 5 so you don't fry your boards. Well, that means that your ohms or your resistance now has to go up to 20. Finally, 500 volts are put into the system, but you want 5 amps to remain in the wires. Your resistance now would have to be 100. So Ohm's law says that as the voltage, it says that the voltage and resistance are in a direct relationship, which means as one gets bigger, the other one gets bigger. Or if you went the other way, one gets smaller, the other one gets smaller. So let's put all these together. Ohm's law says 4 things: that the voltage is calculated by the product of the current and the resistance. Ohm's law also says that the current and the resistance are in inverse relationships. That means as one gets bigger, the other one gets smaller. Ohm's law also says that the voltage and the current are in a direct relationship. As one gets bigger, the other one gets bigger. Or in reverse, one gets smaller, the other one gets smaller. And Ohm's law says that the voltage and the resistance are in a direct relationship. As one gets bigger, the other gets bigger.